So let's now talk about question 3b, which is saying, which is under rotation work, energy and momentum. Yeah. Yes. So here is the question. So the question is saying a hoop of radius 0.06 meters starts from rest and rolls down a slope without slipping. But find its linear and angular speed when it reaches a point of 0.5 meters vertically lower than its starting point. And we have been told that inertia is given by mr squared. Okay. Then part 2 is saying find the linear and angular speed in part 1 above if the slope were perfectly smooth so that the hoop just stripped and does not roll. Now I want you to understand one thing. So let's come up with an incline. Okay, let's come up with an incline. So this incline, we have been told that the distance here is 0.5, the h meters. Okay, then the disk is now rolling. So as it is rolling, it has got the radius. We have been told that the radius is 0.6. So it is rolling until it reaches down. So one thing we should know, guys, is that we have got 2 points here. We have got point A where it started from and point B where it landed. So this is the conservation of energy, not conversation, but conservation of energy, where we say the mechanical energy at point A should be equal to the mechanical energy at point B. What do I mean? The mechanical energy is the addition of all the energy which you have at that particular moment. Now, in this case, we expect to have three energy. We have the potential energy, the kinetic energy, translational kinetic energy, and the rotational kinetic energy, because it is rotating. So when something is rotating, we expect to have rotational kinetic energy as well. So we have got three energy: potential energy, translational kinetic energy, and the rotational kinetic energy. So when I add these three energy, I'm supposed to get mechanical energy. Now there we go. Meaning that I'm going to have mechanical energy at point A, I need to have three. So I have got the potential energy at point A, kinetic energy which is translational at point A, okay, kinetic energy which is rotation at point A, being equal to the same thing at point B. I need to have the same thing: potential energy at point B plus kinetic energy translational at point B plus kinetic energy rotational at point B. Now let's analyze this thing. The question is saying it started from rest, meaning at this point the velocity was zero. So if the velocity is zero, I don't expect to have kinetic energy at point A. So therefore the kinetic energy will be cancelled out because kinetic energy depends on the velocity. Okay, now let's go to point B. When it reaches at point B, it stopped. Okay, when it reaches at point B, it was just moving, but the h was zero. So if we don't have h, then the potential energy depends on h, then potential energy is zero. Now we have remained with potential energy at point A being equal to kinetic energy, the translation at point B, and the kinetic energy rotation at point B. Let's see. Potential energy is mgh. Translational kinetic energy is the same kinetic energy, mv squared. Rotational kinetic energy is given by half inertia times angular velocity squared. Let's plug in the values here. Kinetic energy, potential energy is this. This is going to be given by half mv squared. Then this is given by half inertia angular velocity squared. We do not have m, and we can clearly see that m. So before we go there, we do not have m, so we need to find a way on how we are going to cancel out m. So the first question is the linear speed. The linear speed is v. The angular speed is w. So let's first find the angular speed. Let's first find the linear speed. Then we'll come back and find the angular speed for part A. But we've been told that inertia is mr squared. So I'll replace inertia with that. Let's also try to find a way on how we can manipulate the w. So v is always given by wr. So to make w as a subject of formula, divide both sides by r. So w is v over r. So I'm going to replace where there is w with v over r. So I'll come here and say mgh being equal to half mv squared plus half. The inertia is r squared. Then this is squared again, so it's going to be v squared over r squared because w is squared. At this point I can cancel r. Okay, so if I cancel r, I'll remain with mgh being equal to half mv squared plus half again mv squared. But we can clearly see that we can see mass everywhere, so I'll cancel mass. If I cancel mass, the only thing I'll end up having now is gh being equal to half v squared plus half v squared. My goal is to find the v. So half plus half, I'll end up having 1. So this is going to give me 1. Okay, I'll have just v squared. So when I do that, I'm going to get the square root. So v will be equal to the square root of gh. If we are to plug in the values, what are we going to have? So we're going to have v being equal to the root of 9.8 times h is 0.5. So v will be equal to 9.8 times 0.5. So 4.9. The square root of 4.9 is 2.2. 2.2135. 2.21359 meters per second. Now I'm going to round it off to just 2.1. The reason why I'm going to leave it in 2 decimal places, everything here is in 2 decimal places. You can clearly see. So I'll leave it in 2 decimal places. So you check the question the way you have been given. If it has been left in 3 decimal places, leave the answers in 3 decimal places. It's fine. Okay? So that's the linear speed. Now, I want you to understand another thing here. Let me just get rid of this. We have found that v is equal to 2.21 meters per second. The question was, and is still saying, find its linear and the angular. So this is the linear speed. Let's find the angular speed. So the angular speed is w. Remember we had this formula here. V is equal to wr. So we have now our v. Let's make w as a subject of formula. Divide both sides by r. So w will be equal to v over r. So we have 2.21 divided by the radius is 0.06. Therefore, the angular speed is going to be 2.21 divided by 0.06. So the one I'm getting is 336.8. 36.83 rad per second, because the SI unit is rad per second. So I'm done with part A. Now Part 2 is saying find it's the same question, but they have changed. If it was not rolling, if something is not rolling, we don't expect to have rotational kinetic energy. We are going just to have translational kinetic energy. If something is rolling, we have kinetic energy translational and kinetic energy rotational. But in this case, this is not rotating. That's why the question is, just a minute here, the question is saying, find the linear and angular speed in one above if the slope were perfect smooth so that the hoop just slipped and does not rose. So we get rid of this. So we'll do the same. The mechanical energy at point A will be equal to the mechanical energy at point B. At point A, I have potential energy at point A plus kinetic energy at point A. Now, this kinetic energy is translation. I do not expect to have rotational because the object does not, it's not rolling. It was smooth, so it was just going without rolling. Should be equal to the potential energy at point B plus kinetic energy translational at point B. At point A, I do not expect to have kinetic energy because it started from rest. At point B, I do not expect to have this. So therefore, I'll end up having this. So is mgh being equal to half mv squared. M and m can go, can cancel out. So have gh being equal to half v squared. I want to make v as a subject of formula. I will do times 2 to get rid of the half. So it will be now 2gh being equal to half times 2 is v squared. So v is equal to the square root of 2gh. Okay. So v will be equal to, let's plug in the values, 2 times 9.8 times the h 0.5. Therefore, v for part 2 will be equal to 2 times 9.8 times 0.5. 9.8. 9.8, the square root of 9.8 is 3.13 meters per second. That is the linear speed. Now, I want you to understand this. The question is asking us to find two things. The linear, this is the linear speed, the angular. If the object is not rotating, it is not rotating. So the angular speed is 0 because it's not rotating. So it's 0 rad per second because the object is not rotating. I cannot start using the formula which I use for part A because part A the object was rotating. So part B, part 2 is not rotating, so the angular speed is 0. Okay, so that is it for this interesting question, guys.